In this video, we will explore the initial evaluation of a data cube using the Spectral Angle Mapper and Logistic Regression algorithms as classifiers. In this data set, we have clusters of two different red candies, candy A and candy B. We also have a cluster of mixed candies. The goal of our study is to find out if there is any of candy A in the mixed cluster. For this example, we will use the lasso select tool. Holding the control button, we can select multiple pieces of candy A to create the region of interest, then right-click and select mean spectrum. We will then do the same for multiple pieces of candy B. We can rename the spectra in the tree to help keep track. Now we navigate to the parent cube in the resource tree, right-click, and select New Cube, Classify, then Spectral Angle Mapper. For layers, we select two, one for each class. This generates two drop-down menus. We will assign each reference spectra to a class and click OK to analyze the data cube. You can find a detailed explanation of the Spectral Angle Mapper algorithm in the Spectronon user manual, available at the link in the description. For now, we can simplify and say that the algorithm is comparing the spectra of each pixel against the reference spectra defined by the mean spectra we just generated. If the pixel and reference spectra are similar enough within a user set threshold, the algorithm will classify that pixel as belonging to that particular class. To visualize this, Spectronon generates a color map representing which pixels meet the threshold set by these values in the Threshold to Color Map tab. Here I'm changing the color to make the color map more visible. The sliders can be modified to adjust the threshold value and improve the classification, or to create a better visualization of the data. As you can see, the algorithm misclassifies the edges and the brighter spots. To highlight the benefits of different classifiers, we will now explore logistic regression to perform the same classification. The setup is similar to Spectral Angle Mapper, and we will again use the lasso select tool to select. Instead of selecting mean spectrum, we right-click and select Create Cube from Selection. This creates a new cube from the selected pixels. It's okay that the new RGB images look confusing. These new cubes get reshaped, so the RGB images won't look like the original cube. Now, we repeat the process for candy B. Finally, we do the same for the background. Logistic regression returns a probability for every pixel in a cube, so we need to classify the background as well as the candies. Once we have created our three reference cubes, we return to the parent cube, right-click, select New Cube, Classify, and then Logistic Regression. I leave the default settings alone and select 3 for the number of classes. In each class, in the Cube drop-down menu, select one of the 3 reference cubes that we generated. Click OK. In the Threshold to Color Map tab, I can make the color for my background class black and the candies to match those chosen for the Spectral Angle Mapper color map. We will make candy A red and candy B blue. Right away, we can see logistic regression classify the edges better, and as I click between the two color maps in the cube tree, we can see where Spectral Angle Mapper missed pixels inside of the candies. Logistic regression still misclassifies the edges. Modifying the threshold or using a different classifier could still provide a better classification. To answer our original study question, we can say definitively that the mixed cluster contains 3 pieces of candy A. Using the color map, we can clearly see which pieces are candy A and which are candy B. As always, thank you for watching.